Good afternoon, everyone. Thank you for joining us with this another lunch and learn session with SIMTEQ Engineering. We are pleased to welcome Yuanyuan Wang from Hexagon. She will be hosting or presenting on Odyssey with us today. So, Yuanyuan, thank you very much for joining us.
Thank you.
I will hand over the reins to you. Thank you.
Yeah, okay, no problem. So shall we wait for several minutes for more audience, or we can just start?
We could maybe start. We could maybe start with a short introduction.
Okay.
So if you don't mind explaining to us your history and how you happen to be in the Netherlands. And of course, I'm going to ask you a very important question, and that is if we South Africans have the same English accent as the Dutch.
Well, for me, it should be the same. But even that, I think some of South African people also speak different version of Dutch. Yeah.
Very, very different.
Yeah, very different. Yeah. Okay. So yeah, I can do a little bit introduction while we are waiting for more audience. So my name is Yuanyuan Wang. I hope you can see my screen.
Yes.
Okay, that's good. So hello everyone, my name is Yuanyuan Wang. I'm based in Netherlands. So I moved to Netherlands I think 10 years ago, and my background is more from the aerospace. So I do aerospace composite study, I think long time ago in TU Delft. It's a technical university. And after that, I working for the simulation industry. So in Hexagon, my role is more focusing on the AI solution, and also Digimat is a material solution. So I support the business for EMEA and to introduce the new technology and to do some business, to do some technical update. What is the new feature of different product, and to discuss and exchange with the customer. That's how we can implement, like for example, AI solution. So the industry is quite broad, and what I can share with you is that let's say that maybe 2 years, 3 years back, AI is still kind of like new topic, hot topic for the engineering company. But now we see that more and more company is not only the innovation company that who want to implement AI. It's more like that the real usage. So the design department, the engineering department, they already start to see that AI is already a tool that like the elements that they need to implement in their daily work. So that's why that I'm really happy and honest to have the opportunity that we can talk about and exchange about Odyssey here, and to introduce more about the AI solution from Hexagon. So I'm happy that I have this opportunity to show here. And I think we can start the presentation now, right?
Yes, thanks.
Okay, good. Okay, so then let me move to the next page. So like I mentioned, so I prefer this industry will be more interesting and interactive. So if you have any question, please feel free to put in the chat. And also that I will not really talk about too much technical stuff like mathematics and also algorithm. So it's more focusing on the application and what can be some practical steps that what can be done in Odyssey to give you a general overview. So before we go for some technical work, I also would like to show, because I oversee the whole EMEA and I also support a little bit of the global client. So I also want to give you kind of like taste about how the AI solution, maybe not only Odyssey, but also the general AI to be used in the whole simulation industry. So you may use also like ChatGPT, whatever, Gemini for your daily work. And the trend is that in the past, like I said, that is mainly for the innovation project, that people would like to curious to know that what AI solution can help in their daily work. But now I think the application became more solid. So I can mention several scenarios, like for the consulting company or design department. Let's say that the company already have large simulation database, that they run lots of simulation in the past, but they didn't really reuse the simulation results. And time to time that we see the potential of those simulation data. For example, let's take a yard shape building company, design company. So the yard size, let's simply say that the size of the yard is different one by one. So it's really customized. So you can't really design from the scratch. So what normally the shipbuilding company is that they design based on the previous design. So that's why that you may also implement like SPDM system, that you have the sim manager, for example, is also a product from Hexagon, that you manage all your previous simulation data. And if you already have those kind of group of data, simulation data, and why not use your previous design, either is the simulation or the CAD file for your new project, new customer requirement, then that's where that Odyssey or the AI solution can help. So where that you can manipulate that your previous simulation results and to create the new design. So this is really in the initial design phase, that to optimize your design and to see that what will be the best guidance for your next phase. And another scenario is more for the parameter study, let's say, or for some optimization. So instead of like in the first phase of the design, that we can think about, for example, I see some audience from aerospace industry. So you may design a aircraft part of the body with the stifter. And then we always compare that if we need to increase or decrease the number of the stifter, or we need to make the stifter more stiff, or increase the stiffness. So there's several ways that you can do. You need to balance, and also that depends on the KPI, the output. So either you want to increase the number of the stiffener, then you need to increase the weight, but on the other hand, you increase the stiffness. So there will be balance about the parameter that you want to optimize. So that's where that you can also use Odyssey to use. Or take another example for the automotive industry. You may want to increase or decrease the thickness of the door, but on the other hand, you also want to reduce the noises. And then you can also make different choice of your parameter for the new foam material to reduce the noises. But then you also need to balance about different parameter. So you can, of course, run lots of simulation, value of simulation to get the results. But on the other hand, what the AI solution can help you is from mathematically way to see how you can optimize those parameters. So those is two scenarios that I want to share with you, that there are already more and more industry, more and more company that they already adopt the AI solution in their daily work. So it's the time that you can also think about the workflow or the user case, that where you can also see the potential. I will not only mention those advantage that is unfair. There's of course a limitation for the AI solution. It's not only the limitation for Odyssey, but for the whole AI solution. One of the limitation will be the database that we have to train the AI. So you can imagine that we, no matter what kind of AI solution, is highly rely on the data set that we have. The accuracy is highly rely on the data set. But that's something that we will discuss later, that how Odyssey can help you clean the data, or to slightly the parameter to minimize the parameter influence in the whole simulation. And another limitation is that we need to be realistic, let's say. No matter Odyssey or other solution, AI in principle is a mathematic way. So if we want to get accuracy results, we need to do the interpolation. So if we want to do, then we have a boundary condition. I will also show you the case later on. So if we do the simulation in the physical scenario, in the testing that we already know, in the range of, in the boundary condition that we run the simulation, then the the accuracy will be very high. So the meaning is that all the AI simulation that is based on, let's say, train the data, fill in the data, is based on the memory of this mathematic solution. And then we do the interpolation. So if we want to do the extrapolation, then the result will be not accuracy enough. Let's say that example that, so if we want to predict a fatigue curve in high temperature, and let's say that we have the testing data from room temperature 23 to 100 degree, and if we want to really predict the temperature in 300 degree, then the result will be not accurate because we don't really see what is the elastic plastic performance after high temperature, after 100. So those is something that we need to keep in mind, that how we handle the data set that we already have. So we can have a good result if we follow the principle, let's say that to build the learning path within the training domain. So those is the 2 points that I want to share in advance. And I see that I talk too much on this topic. Then let's go into the point here. Let me see. Yes. So for today, I will focus on the Odyssey part, what we can implement into the failure element simulation. And for Odyssey, I will focus on the CE. So let me do this. So the CE part, which is really coupling with the failure element. And I will do a little bit short introduction about AI. So this is more for the imaging processing. So I will just use some example to give you some assets. And about the solver, so this is also have 2 parts, which will not really touch base too much here, but just give you a general idea. If you are really good at scripting, I know most of them that you are the expert for failure element, then solver can be one of the engine for you to do the artificial intelligence or optimize. So there is 2 possibility in the solver. So one is the quasar. So this is you don't need to remember the name now, but this is objective-oriented programming language that allowed you to configure it that the computation for the data mining or prediction or something like that. So this is more that you can do by yourself with this solver to combine with your current simulation tool. So, and you can see that we also mentioned we can do together with Cradle, Nastran, or DigiMat. And we also have another one, another model inside the solver that is the optimizer. So that one is more for the for connecting the data and to do some analysis. So I will not go too much here, but today the focus will be the CE part and the AI part. So to be simple, what we can do in the CE will be a simple workflow that I show here. So we assume that user will have some simulation already finished the simulation. So then you already have some input and output. Let's say I will not really set up any limitation here. That can be fatigue simulation, can be NVH simulation. So because CE itself is a mathematical algorithm solution on behind. So for Odyssey itself, there's no difference between what we say the NVH or what we say for the crash simulation. For them, it's all data. Then what we do is that we fit in the data, the simulation, the file element run that we already have, the input file and also the output file. That is what we link here, and that can be CSV file with all this information or text file. So when we have this fit-in data set, then Odyssey will learn itself. They will train the data, and they will use what we call machine learning, artificial intelligence, and also what the core in Odyssey is the reduced order modeling. So it's kind of a mathematical solution to learn itself about what happened between the parameter and the outcome. So there will be a learning curve for Odyssey CE to know what will be the reaction if we want to give input of the new parameter. So you see that then we have 3 type of input. Two of the input is coming from the simulation that you do in previous job. And then when you want to do the new design, you will give another input. This input will be the new parameter or new simulation that you want to use. So then at this point, they will give you a prediction result. And also, like we just mentioned, Odyssey itself is a mathematical solution. They will not go for the failure element run. They will not solve the physical equations, which means we will save a lot of time. Normally, that per run of the Odyssey CE will save a second or maximum minutes. So in this way that we can generate new simulation results, but still based on the relation that we already have in previous simulation. And this AI is not the focus for today, but just in case that you have interest. So AI is more focusing on the imaging or CAD mode, the geometry. So if we use imaging or CAD as input, so what we do here, then what AI can create is customize the AI application that will predict the outcome output of the response and the field data. So just I think I also have some example at the end, but the main purpose here, the scenario that you can use is, for example, some defect testing to see that if you really produce some part, no matter what is the manufacturing process, and you have the image, and then you can predict if the part will fail or not, depends on the imaging. So that's really also a way that all the manufacturing industry, all the factor will be used to see what will be the influence and to detect the defect in an early phase. And of course, as design engineer, you may also have the CD model, and you may want to know what will be the influence of the different geometry, maybe the size of the block or the different faster location or injection point. So those something that Odyssey AI will do. So this is more for imaging to predict the result. So to summarize here, so what we already discussed, the input for Odyssey can be simulation data, can be testing data, and also can be imaging. And also additionally, we can also read sensor. So which means that, let's say that what is very hot topic, digital twins, you want to have the real-time simulation or you want to do the real-time detection. So that is possible by using Odyssey because it's really solve the issue in short time. And before we go for the case study or to show you more detail, I also would like to show you to explain a little bit more for the reduced order model. So we call it RAM here. So basically it's 3 steps. Even I will talk a little bit of this concept here, but it's not mandatory that for the user of Odyssey to fully understand or to do a study here. So we have different algorithm, and you can make you can make the choice to optimize the algorithm, but it's not necessary because Odyssey is very simple workflow. It's not really mandatory that you are master of this different algorithm. The reason I show you here just give you a bit of idea what is behind in Odyssey to run. So this run is kind of a way to calculate based on mathematical way. So this is to reduce the computational complexity, and this will be used for example, CFD structure or thermal simulation. So this is very common method if you talk about failure element AI solution. And the concept is that we all know that in failure elements that we have the high digressional calculation, and the calculation time, if we need to run CFD or thermal, it will be very high. And the time it will be very long. And what we have here is that we try to dimensional the decompose it, the calculation time, and to simplify it by using this mathematical way. So in total, we have 3 steps. The first step is that we, let's say, disassemble the data set that we have. So one of the solution is that we call, for example, SVD, is singularity value decomposition. So this is how we decompose it, the initial data. So the key point is that we still want to keep the key feature of the data model. So if it's a CFD one, then we want to extract the mean flow of the structure. Then when we have this mean model, mean character of this data set, then we will go for the second one. So the second step is to reduce. Still, we want to keep the feature that we built from the first step. Then what we want is to build a low dimensional and also the model that will maintain the feature that we mentioned. And then the final step, so we calculate per reaction, per low dimensional input, and then we do the reconstruction here. So the reconstruction here is to recover what is in the first step, the complex, the original system. Then we assemble again the simulation, the simplified model result, the result from the simplified model before. Then we use the previous extracted basic function or models that to go back with this low dimensional result and to project it back into the high dimensional space. So this will give you a fast solution, but reduce the computational time very efficiently. So that's why that we can really save the time from the failure element simulation into the mathematical way. So here is a simple way that how we do this reconstruction. So you see that we should have a complex reaction between the input and output, but how we can also disassemble to decompose it into different feature, to extract the feature, extract the model per reaction, and then we do the reassemble. So those three is just the example here, and just give you more simple overview that if the previous one will be still a little bit complex to explain, is, for example, we play different instruments and the frequency will be different. And at certain point, at certain second, we actually hear the reaction from three of them. But if we disassemble and each reaction will be simplified, and if we calculate the per instrument and the reaction, the calculation time is low and is simple, the reaction is more consistent. So then after we do the disassemble and we go back and we can have a sample reaction. Then when we give a new input, maybe a new time frame or new frequency, then we can easily to see what will be the assemble result from here. So until here that we finish the core concept about Odyssey, how it runs in background and what is the mathematical algorithm that we use, and why we explain why we can save time. So here, just to simply say that Odyssey can combine with, sorry, let's go a little bit fast. So Odyssey, they can combine with all different solver. So sorry, I don't know why it goes so fast, but what I would try to say that in previous slide, no matter what solver that you use, still at like we mentioned at the beginning, it's not really taking the physical performance. It only rates the data set, which means that no matter you use Marc for thermal simulation or use Nastran for linear simulation or Actran acoustic simulation, for Odyssey is the same. They can work with all these different solver because you have the CSV file, you have this input, you have all the element and node, then they will rate as input file. So no difference. And on top of that, Odyssey is not only limited to Hexagon solution. If you have other solver, then Odyssey can also do the coupling simulation, do the analyze. And then I think the traditional FEM workflow that everyone already familiar. I know that you are all the expert here. So normally that we do the CAD modeling, we generate the CD file, the geometry file, and then we create it by this discretely to generate the element and node to have this value element point and for the numerical calculation. And then we may have some like boundary condition load. So those traditional way that we use the value element solver to solve the physical equation. But now what we do, like we mentioned in CAE, is that instead of instead of this physical equation that we need to solve, this especially for this repetitive calculation, for this maybe multi-load case analyze, we use the RM that we just mentioned in previous page, that we only need several high quality simulation results. Then we train the model and to use the solution, use this mathematics solution in order to not mesh again the geometry itself and not run this physical simulation to predict the new scenario, let's say. So then what the beneficial for us is that we only use a small amount of high quality sample data. So if you have 3 run, 10 run is already enough. Then we can quickly resolve the issue even you have new input, when you have the new input. So the calculation time is very low because we don't need to go through this remeshing, we don't need to resolving the simulation. So the workflow here in Odyssey, what we need, the input, simulation file, testing data, or the data from sensor, all is possible as long as they are data. And what we do is that we separate the data that we have in 2 different sets. So one set we do for training, and the other data set we have is for validation. So the training part, normally we suggest we leave maybe 70% of your simulation data set, and we leave 2 or 3 for the validation. So when we have this data set, we will fit into Odyssey, and in Odyssey, they will learn from the input and output file. So to be clear that the data set is not only the input file, it's actually a finished simulation file, the whole simulation include the result. So then the Odyssey CAE, they will train themselves, they will learn the simulation path. And at this point, after they finish the learning, it's very quick, and you can give the new input. The new input can be XN, which is the same here. So but here the output will be the simulation output. So what is predicted by Odyssey CE. And what you can do here to bring back the validation point to compare. So on one hand, you have the simulation prediction result. You have the prediction result from the Odyssey AI solution. On the other hand, you have the simulation data which you already run. Then here that you can combine if the result is matched, if it's accuracy enough. And if it's not, maybe we need to change either to add more DOE, maybe the DOE set is not right, maybe the boundary condition is not correct, then or we need to choose another algorithm because it's more data, the data set is big, we need to use the RAM. So those something that we can modify, and we can either we fill in more data or we change the algorithm, then we retrain the model. So those is the general workflow that we will have for the CE. And before I go to each step, I will show you, so you see those is the outcome that we normally have. So in the previous second is the curve that we can have, but we can also generate the animation. So you just see here. So that means that when you run the simulation, when you finish a simulation, although we say that we will not run through the file element at behind on the background, but we will run the mathematic way. When you may generate, for example, 10 different result, and you choose the optimized way, and you can generate the animation to see in which step, in which second, like the history of per step of the simulation. So that is repeatable, comparable with the file element process. And you can imagine the output can be like what you see here, the animation, and can be also the picture. And that is very useful if you do, for example, drop testing. It costs a really long time. Or if you have some static structure simulation or thermal simulation that you also need a color map, or for example, car crash testing. So per step reaction, per location, per element will be very important for you as outcome to review. So okay, so I have just one more page before we go for the detail, the capability of the CE for each step. So just one to repeat myself. So we say that we have Odyssey that is purely data driven, and on the other hand, when we run file element, we have this partial differential equation that we try to solve. This is more for the physical file element one. And here is the limitation that I talk at the beginning. So we would like to, as we are purely AI based, purely mathematic based, we will solve the issue based on the data that we have, not the physical we have. And if you really want to, so that's why that we do the interpolation. If you want to simulate out the boundary, so above the temperature you implement or above the frequency that you simulated, then we need to combine with a little bit of the physical. So there are also solution like physical informed AI or called hybrid model, where you can embed the partial differential equation into the AI solution. So there are solutions there, but it's not in today's topic. So we now today will focus on the data driven. And if you have interest to combine with the physical performance, you should also contact us, and we see that what we can do for you. So now we go for the detail for what we can do in the Odyssey AI. So you see it's very straightforward. There is let's say 6 step or 7 step if you want to use user subroutine. So it's very easy to use. It's very user friendly, and they're already step one by one. So it's kind of like the guidance. You don't really need to be a machine learning or AI experts to use this tool. It's very user friendly, and they also have a document online that is open source, so you can already check the video or the document when you start. And also that you don't need too much as input because you already have the file element run in before. So the training will be done. The data training will be done by Odyssey itself. The only thing you may need to be familiar a little bit is different algorithm, but at the beginning you also don't need to know what is you don't need to master the difference between different solver for now. You can always contact us to see what we can support you there. So it's very easy to use, and there's not too much you need to do to prepare for this input because you already have your file element run. And also that even we say that the more data you have for training, more accuracy you will get. Still, that if you only have limited database, it's still okay to start because we have the algorithm that we have dedicated for small set of data. So even that you didn't run like, let's say 100, 300, I think we have a case that you only have 10 simulation result or 9, then we can still do a good prediction. So I will from here to give you some really physical view, the real view that what will the interface of Odyssey look like. Before I play the video, I need to be honest that I record a video in short time and I record by Teams, so the quality is not so good. But I will try to explain because the number is not that important to see. So this is the first step that you have the data. I know it's not that clear. So after you create a new project, you can import the data. So now what I have is 20 different input. So this input X, you can have a sickness or yield stress. What I want to show here is that you can choose either you consider sickness or you consider both of them. So you can also deselect one of the data sets. Either is from the input parameter itself, so the whole yield stress will be deselect, or you say that you may see the similarity between dataset 2 or 3, then you remove one of them. So that is very flexible for you. And on the other hand, sorry, give me 1 second. Why I can't play the other? Okay, sorry, I should pause. Okay, so then on the other hand, you will have the output. So this is also the simulation result. So you see that in total we have 20 case, so 20 points. So in each, so previous case that we have 20 input, 2 parameter, thickness and yield stress, and here we have here we have 20 corresponds the result. And what I want to, 1 second, sorry. What I try to show here is that you see we have 20 of the outputs. We can select all of them as the train model, but we can also save maybe 1 or 2 for validation. But what you notice here is that you can't choose one test case from the export, from the output, because that only can be changed from the X value, from the input value of your value element, because that is linked with each other. So if I go back here, if I remove the section 2, then automatically in the train model that the output value will be not included. So this is more useful for the validation part. You can leave 1 or 2 set for validation. Or let's say that if you want to clean the data, you already realize that 2 data sets already duplicated, or the data is already out of the physical meaning, then you can deselect the data. So there are all possibility that you can have. And then we go for the next step will be the sensitivity study. Let me see. So this is also a good part for Odyssey, that you can pre-study your data. So parameter study, let's say kind of partially parameter study that you can study. Let me see. Yeah, it's going on. So what we see is that you can see the parameter effect on this step, on this sensitivity step, that we can see the response of the responsible curve in the Odyssey CE. So what we can do is that we can do the sensitivity study, and this step is allowed you to know the influence of the parameter on each step, or each time interval influence. So this is very good. That also what you see here on the, let me bring back the laser. So what you see here, so those 2 pictures, if you link that together, is that in certain time step, you will see 2 parameter and what the influence for the outcome. So those curve is the outcome, and you can see so this is the regression coefficient about between the input and output. So if I say that what you see here is that let me move the video a little bit. Yes, no, sorry, I need to bring this back up. Okay, so what you see here, the point is not that clear, but you can see that they have a decrease trend of the thickness when I increase the input. So what we're trying to show here, so those 3 picture, for example, 3 analyze is dynamic and is all linked together. So at the bottom is the parameter effect tab, that you can see that with this bio plot, the influence of the parameter on the responsible curve. So in this case, when the thickness value is increased, so here increase the thickness value, and the responsible for the output will be reduced. So that's also corresponds consistent with the negative coefficient. So you see this is negative coefficient in this picture. On the other hand, if we see the yield stress, so when we increase the yield stress, you see the curve is very random. So it's very clear to show that the influence at this moment, the yield stress play very, very less influence role compared with the thickness. So that's how you see the how you compare with the different parameter and the influence of the parameter effect. And also that we have here different criteria analyze. So this is another way that you see the parameter influence. So what we have, later on when it, let me see. Oh, sorry, I forgot to mention. So what we just see, the relation is in the first order regression, but you can also play in the second order regression, but it's not mandatory, but give you more overview about the relation between different parameter and output. Okay, so back to this criteria analyze. So you see we have more option that add value at the interval and can be the minimum and can be the maximum. So I will show you here. So you can see, yes. So here will be a good point to show you what will be the scenario good to use this different criteria. So for example, at each point, so this is interval, but you can imagine if let's say I only see a point, you can analyze the impact of one parameter at each time point through the entire time scenario. For example, let's imagine that I have a case study that I need to analyze at the second one, after 1 second, what is the biggest impact from the parameter, then you may figure out thickness will be the great impact. At the meantime, that yield stress will have no impact or less impact. And then you can move this cursor maybe to the 3 seconds, and you will see that at that moment, maybe the impact velocity will play a big role. And you move again this cursor. So then you will see at, for example, maybe the 5 seconds, if we think about a door structure, maybe the great impact will come from the yield stress from the material. So that's why that is very suitable for this criteria analyze if you have a dynamic analyze. So you can observe how the impact change from different parameter over time. So this is more for the dynamic simulation. And what I show here, so now if I say that I want to create an interval, so the time frame between 5.5 to 14 at the step, then for this one, that what we see is that the minimum will be the blue curve, and with the right one, the maximum. So we select a time interval, and let's say that if it's 2 seconds or 6 seconds, and in this system, what we'll find will be the minimum deformation within this interval, and analyze which parameter have the great impact on this minimum value. So in this one, what you see here is that for this scenario is very suitable for analyzing the parameter impact when the minimum deformation is a concern. So let's say you have a safety design requirement and you have the minimum result and you want to see that what will be the impact. So this is more for design or safety design. So those all the function, but of course we have more like different statics study and also standardize if we have for example, stiffness, thickness and yield stress. Actually, they are in different unit. One is the thickness, one is millimeter to centimeter, and one is megapascal. Then we also have this standardized tool that we can make sure that these two different field input can be compared. So I know I may be too slow for the video, so I will go a little bit quick on that. So here in this video, what I try to show is we can do the first prediction. Let me see. Oh, I hope, yeah. So just emphasize one more time again. So you see that I have the thickness control between 1 and 4, and I have the yield stress control between 100 and 40. The reason is that this is the boundary condition that we have as input file. So I need to emphasize here again, because we Odyssey is to do the interpolation. So in order to have high accuracy, we suggest you predict in the range that you give the input. So if you have the thickness between 1 and 4, and if you say that I want to predict the scenario for 10, then it out of the physical domain and also out of the mathematical algorithm range that we can simulate. We can still do, of course, but the accuracy will be low. So you need to pay back for the accuracy. So that's why that we have this range suggestion that's within the input range that we can do the prediction. So if I video, continue the video. So let's say before that we talk about how we clean the data to make sure that the input file is accurate enough and is in the right range. And once you check the parameter effect, and then we can change to this parameter set, adjust the parameter set, where you see that I give a new input. So the thickness and the new yield stress. So this 2 points is not from the simulation that you already done. Actually, it's the new input that I want to simulate. So you can see this is a new case that I use Odyssey to run. And yeah, you can also there are also possibility that instead of you give manually, if you have multiple parameter like 10 or 15 inputs, you will not really do one by one. Then you can also import the CSV file to run the prediction. So in this way, that what we do is to set up the value as input that we want, and then you can make the prediction of based on the trained Odyssey dataset. And yeah, it's very simple that you click the run and you see the result in Odyssey and it will show immediately. And I didn't really add the speed here, so you can see that how fast that each result will show you is very quick. And I move a little bit further here. So what I want to show you here, you see the curve actually is very good match with the physical. So those colorful case is the new one that we do the prediction. So it's the new prediction result we get from Odyssey. But what I also repeat myself. So if you see that's all the new set will within the curve that we gave as input. So then they will have a really good accuracy match with the physical scenario. So then yeah, so those is what we can have. And of course you have more option that if you want to focus on one simulation scenario, or if you want to hide some of the curve. And here is also the point that if you want to bring back the validation data set, then you can also do a comparison here. So there are also more options that I didn't cover in this video. For example, we also have the DOE design, DOE generator. So if you don't have enough data set, for example, you have one or two simulation, finish the one or two simulation, then we also have the DOE generator that you can generate more case. And also we do together with Nastran. So we have some workflow also here that if you have interest, if you are a Nastran user, please contact us. We can show you more video workflow there. I'm sorry that I'm a little bit slow, so I will speed up a little bit. So here that we talk about the mathematics solution, the solver that we choose, the interpolation solution that we have. So for now that still, like I said, you don't really need to see the difference here. So we have really a lot of different solver that you can do interpolation methods directly interpolate with those, for example, ARBF. So this is really a good one that we can do both for the curve data prediction, but it also suitable for the imaging one, and that is good for generate the animation. But also we have more like the RM in the RM method. So then we have more that we can generate animation. We can use for imaging, and that is also good for the big data. So all periodical time response. So the solver, all this solver is really depends on your input, and also depends on the size of your database, and also depends on what will be the output that you are looking for. So, and all different solver will give you different time. So the responsible time will be different, and also the CPU, the needed CPU resources will be also different. But here that what you can contact us, we will give you the suggestion based on your user case. Okay, so, and a little bit I think interesting to show you here is that we also have this reduced model algorithm that's to create the real-time animation. So what you see here. So normally in the what you see here before that we show in the sensitivity study that we show you the curve, how the response of different data set. But of course, we can generate the animation, so you can compare with your validation case. So what we have here is that we create the real-time animation of a failure element simulation for new parameter set. So what we gave as new input, and when the animation is finished for the first time in the project, a learning algorithm will be also implemented. So for this animation prediction, so for the same solver type, like I mentioned, that there are solver in previous page. Not all the solver is suitable for generate animation, but let's say that if you choose the solver that is suitable for both animation and also the curve prediction, then you don't need to repeat the step here. There will be already so let's say that there are no learning phase to be trained, to be run, but you can automatically select the animation to export that. So that will be further save your time. So I know there are more options that, but we are limited of the time a little bit. So I put some of the example here. So still, like I said, we only show limited case study here, but if you have more that you can think about, that you have your failure element simulation done, please contact us. We can see, we can help you to see the use case, and we help you to see how to implement the solution. I just quickly go through these three. It's very simple to understand, I think. So the first one is with the acoustic simulation combined with Odyssey and used to build a RAM and to predict the transmission loss in the motorcycle system. So you see the geometry actually is the Mu-Fleur and also the catalyst coverage. So that will be optimized and without run the simulation in action itself. So that can help you to improve the efficiency and also to check the performance in a short time. And the second one will be more easy. So we actually combine with the Nastran simulation result. I think here in this case, we only use 10 simulation. So you see that how minimum data set we need is really not too much. So what we do is for this front and bending simulation and the point mobility at the damper top. So what Odyssey do is that we use this 10 Nastran file and to do a parameter study, sensitivity study, to identify what is the key design variable to have the influence for the X-Relin pack. So that's something that we can do to compare the Nastran simulation. So what OTC do is in second. So we can run per run in second. So which means that if you give more parameter or you want to do the parameter study or sensitivity study, even that you have 100 data set, you can finish in minutes. And the last one, more for the semiconductor industry. So what we do here is more combined with the Marc simulation. Well, not the failure element coupling, but we use the result from Marc simulation. So what we do is that we use ODCCE to build a RAM still, use only 3 input parameters to predict the chips manufacturing process temperature, and also the lead stress, and also I think we also consider the displacement under the overpower peak. So you see that the input can be multiple, 3 or 4, and if you want can be 10 or more. But the more parameter study you do, the key parameter that you will focus. 2 or 3 or 5. So in this case, a sensitivity study can identify what will be the key factor affect the thermal expansion and the stress in the microchips structure. So here will be all until here that I show you. I hope that you have a basic feeling about ODCCE, and I will be quick to show you what imaging can do, what we can do. So this is a separate model from ODCCE. This is a new one that we called AI. So this is more for CAD base or image base to learn the model, and it's still very easy application that we can create based on some picture database. So what we do is that either you have the input is the measurement or imaging or let's say 3D step file, then that can be the input data, the resource that we have. So you see here that we have from the automotive, from the tire, that's all different design, and then we link with the acoustic result. So what we do here is that we give all the different picture here, and we also fit in with the output file. And what the user need to do just to give a new picture, new design of the tire, and then Odyssey will give you output of the acoustic simulation. So we in AI have some embedded solution here. So all this solution is already developed. So it's kind of small application inside Odyssey AI, which you can do for automotive, for aerospace, for healthcare. But of course, you can also use another type that build your own customized imaging process solution. So in case you have different scenario, for example, if you are a factory that you produce lots of the part, maybe from the, so this case is from casting, that you have this 2D imaging to want to check if the quality of the cast part is good enough, then we can identify where is the defect, if the component is qualified or not. So you don't really need to do a 3D 5D or 3D drawing. It's only the imaging processing to extract the picture. So you see the picture that they take from the picture itself, and to compare with the one that you gave as the input for the training model, the reference model, the reference imaging, to do a prediction. So I think in this case we have about 100 imaging, and then we can do the AI inspection and to automatically to inspect the new product if it's qualified or not. So this is really good for the industry development. And also one of the model that we already have in for this case is to predict the lift and the drag coefficient from the aircraft, from the cross section of the imaging. So you can see that you can change the design, you can generate a new the lens for different part, and then automatically we will calculate we will calculate the output, the aerodynamic parameters for that. So in this case, I think we only use 16 parameter, 16 imaging, and also that we can calculate the simulation in minutes. And I know that some of my colleagues, they also work with a medical application to detect, to read the CT scan result. So that is similar, that you can have different parameters that to see that how the influence, and to see that if the patient need to have some, need some help. So to be short, the application for the AI, the scenario will be very different between industrial. Even in the same industry, in the automotive, depends on the performance that you are looking for, acoustic, thermal, you can have very different application. And the only thing we need is the picture and also the output that you have as reference. Then we can train the model, and in the next step is that you fit in you gave the new input, and we see that if it's qualified or not, depends on the application that you have. So I will not really go for Nexus Enrich too much because we already run out of time, I see. So just one, sorry, it's not working. My computer is frozen. Okay, sorry, my PowerPoint closed. I need to reopen. So yeah, just to, I'm not sure. Yeah, I'm still in the meeting. That's good. So just one last comment. So we also have this Nexus 2. So it's also another AI solution from Hexagon that we generate the material data based on your current simulation based on your current data set. So this is on cloud, and you can generate new composite material data in different temperature or different time testing scenario or different fiber orientation or different fiber percentage. So this is also a little bit, this is also combined with the algorithm that we have, but also this one is what I mentioned, that we also introduced the physical equations behind. So it's a little bit extrapolate. So where we can simulate in different temperature, even you have one temperature as input, we can simulate extra temperature, maybe 80%, 80 degree or 100 degree. So those something that we have for, if I stop here, so those something that we have on cloud, and it's very easy to use. You don't really need to have knowledge for AI, and you see that if we have fiber volume in different scenario, but if I want to have a new design for 40% of the fiber volume, there's something that we can predict. Or if you have the temperature for room temperature 23 and 120, but you want to predict 80 degree, then that is also possible. And soon or later that we will also involve some humanity simulation, but it's not yet there. But we do have the capability now to predict the fatigue data, creep data in the cloud solution. So I'm sorry that I talk too much. There is free trial both for Nexus and for Odyssey. So please feel free if you have interest to try those two, contact Paul or contact us so we can help you from there. That's all from my side. I hope it's kind of useful for you guys.
Thank you very much, Yuanyuan. Really appreciate the time. I've also picked up on a few details that I've learned myself today. So I really appreciate that. I see we've reached the top of the hour, but if there are any questions, you're more than welcome to quickly ask. And otherwise, we can also address it via email or text later on. But if you have a question, you're more than welcome to raise your hand or put something in the chat. I see that there's a question if there's a workshop for Odyssey Apex Nastran workflow.
Yes, we have. So you don't really need to how to say. So the coupling between Odyssey and Nastran is not really like we normally have from Nastran to APEC, that you really need to open the file and import the file from Nastran to APEC. As long as you have the Nastran file, the finished file that we can use for Odyssey. So to be short, yes, we have the workflow for Odyssey and Nastran. I think we also have already some plugin interface that you can use for Nastran user. So if you can, maybe we can set a meeting to follow up on this, that we can show you some user case from Nastran, how the usage of Nastran results can be simulated in Odyssey. And
thank you. Andre, I see you have your hand up. Would you like to unmute yourself?
So, Andres, do you mind if
you can go ahead?
Hi. Sorry
explain
about
a
that.
little bit?
Can you hear me?
Yeah.
Yes.
So you said that you've trained your models and that you feed it to the algorithm. Is that algorithm weighted, and how are those weights determined? And then also the algorithm itself, it's something that you guys have created based on your own training material and data? Or is it something that you've sourced from somewhere else? And how ISO protected is it?
So we have different algorithms that you can choose, different solutions. And we also have the algorithm optimizer that you can use to see that if you want to compare different solution. So that is really, well, the mathematical principle will be the same, that we use the open source, the solution on the research industry. So we don't really train the algorithm itself, so that is really on the user side. So we will not, we have our own, so the algorithm is open to all the user, so you can use whatever that you use, depends on the input file or also the performance that you have, and you can compare with different algorithms. But the results, the train model itself, it will be done by the user, not by us. So we will not really, how to say, when you have the Odyssey, it will be only on you. So it's not really. Maybe I didn't make it that clear. So Odyssey itself is on-premise software. It's like Nastran, so it's not really cloud-based. And the cloud-based solution is the last one that I mentioned in Nexus. So that one is cloud-based, that you need to update your data, and there that they will train, but still that you will have your own place that all your data will be protected, will be not used by other, even by us, we will not have no access to see the data that you updated. So it's cloud, but it's only for train the data. It's your own data, but not to mix up. So let's say that, for example, for ChatGPT, that when we ask the question, all the question from you, from me, will be all reused by OpenAI to train their model. But for Odyssey, it's different. So Odyssey, you will use this algorithm, only train your own data. This will not be shared. And the one that I mentioned at really the last meeting, the Nexus, is on cloud indeed, but still the data will stay within your own company. So it's not that open version cloud solution.
Andre, does that answer your question?
Yeah, that helps. Thanks so much, guys.
Excellent.
Thank you. Great.
I see there's another question. Is it possible to create multiple workshops for this process? Customers would use this a lot. The more the merrier.
Okay, I leave this to Paul.
Yeah, so I think that the question is if there's a set of workshops to assist customers using different workflows between Apex, Nastran, and Odyssey. I think in my opinion, the short answer is Odyssey, as Yuanyuan mentioned, Odyssey doesn't care where the data comes from. All that it needs is the input and the output. So you really it's not as if you're going to run it in co-simulation with any of the other products. You basically essentially learn from the input and the output that they generated.
I think, but of course, Paul, maybe is good. We discuss later for that. So I think maybe good that because we already have some workflow example with Nastran that I can share. And Paul can also share. And then it's also good that you can bring maybe 1 or 2 cases that you use a lot in Nastran. And then we can see that how we can help you to train the model there.
Okay, are there any other questions? Then if there's no other questions, thank you everyone for joining. The session will be recorded. So if you are interested in obtaining a copy or revisit some of it, we will happily share it with you. Thank you so much. And thank you again, Yuanyuan, for assisting us in this session. And we will be in more regular contact now.
Yeah, sure. Thank you all. Thank you. Have a nice day and nice weekend soon.